Hello everyone, welcome to this next video on integral equations. In this series, we are solving previous year's questions which appeared in CSIR-UGC NET exam. This question is from June 2017, consisting of 3 marks. The question is, let phi x be the solution of this integral equation. What kind of integral equation is this? This is the first Volterra differential equation because the limits here are variable, right? The lower limit is 0, the upper limit is x, which is variable. So this is a Volterra kind of integral equation, right? And moreover, it is linear because this unknown phi is appearing only once. So this is linear and it is of first kind. Why it is of first kind? Because here on the right hand side we do not have any term containing phi, right? Where x is greater than 0, then they are asking phi of 1 is equal to which of these. So let us see how we can solve this equation. So look at this equation closely. What is this? This is integration 0 to x e to the power x minus t phi of t dt is equal to x. So here what is the kernel? A kernel xt, that is equal to e to the power x minus t. So that means it is a function of x minus t. So these kind of kernels are useful. These kind of kernels are called convolution type kernels. And whenever you have such kind of kernels, a very simple and easy way to calculate these is by applying Laplace transform onto this. First of all, let us see the form of this convolution type kernel. So here in our equation, if you have two functions, say f of x and g of x, right? And this operation is known as the convolution operator. Convolution operator. Then it could be written as 0 to x, integration from 0 to x, f of x minus t, g of t dt, right? So this is the definition of convolution operator, right? So here you see in our equation we have this kind of thing with us. So the equation could be written as, e to the power x convolved with phi of x is equal to x, right? So we could write our equation like this. No problem in that because this is the definition. Moreover, now to solve this, what we do, we take the Laplace transform on both sides. What is Laplace transform? It is a transform which converts the function from one domain to another. We have the domain of x, we take it to some other domain of p, say, right? And by applying this operator, what is the definition of this operator? That means you are finding the Laplace transform of f of x, that would be equal to integration from 0 to s e to the power minus st f of t dt, right? This is the definition of Laplace transform which we would need over here, right? So now let us apply this operator to see what do we get. So we have Laplace transform of e to the power x star phi of x is equal to Laplace transform of x. So now we should know some formulas to solve this, right? Formulas of Laplace transform. So there is one important theorem known as convolution theorem in the theory of this Laplace transform. What is that? That states that if you have a function f of s, then the Laplace of f of s is equal to some f of x. Say Laplace of some function f of x, that would be equal to f of s, and Laplace of some function g of x, that would be equal to capital G of s. Or if we are talking about in the p domain, so let's call this as f of p, and g of p, right? This could be some function. This we say that we know that what is this, right? So the Laplace transform of f of x star g of x, that would simply be equal to the product of the Laplace transform of g of x multiplied by the Laplace transform of f of x, right? Or we can write this as simply g of p multiplied by f of p, right? So we can use this formula over here. What do we get? We would obtain the Laplace transform of e to the power x multiplied by the Laplace transform of phi of x. And what is the, there is another formula. That formula is, what is Laplace of x to the power n, whatever is the power of n. It would be n factorial divided by p to the power n plus 1. So here in our question, what do we have? We have x to the power 1, e to, right? We have x to the power 1, so our formula becomes, here it becomes 1 factorial, that would be 1, divided by p to the power 1 plus 1, so that would be p square, right? And another formula we have Laplace transform of e to the power alpha x, that would be equal to 1 upon p minus alpha, right? This is another formula. So let us use these formulas. What do we get? We obtain 1 upon p minus 1, because alpha here is 1, the coefficient of x, and the Laplace of phi of x, we do not know this. So let's keep it as it is. It is equal to 1 upon p square. So let's move this quantity onto the right hand side. So we would have p minus 1 divided by p square. So we just separate the terms to see what do we get. So we have Laplace of phi of x, that would be equal to 1 upon p minus 1 upon p square. To obtain this function phi of x, we just have to take the Laplace inverse. So that would be Laplace inverse of 1 upon p minus Laplace inverse of 1 upon p square. I could write down this as this, because this Laplace operator is a linear operator, right? So Laplace inverse of 1 upon p, it is equal to 1, and Laplace inverse of 1 upon p square, we just saw it was x. So these are the formulas. If you do not remember the formulas, you just go back and revise your formulas from the theory of Laplace transforms, right? So phi of x is equal to 1 minus x. So in the question, what are they asking? They are asking what is the value of phi of 1, right? So let us calculate the value of phi of 1. So phi of 1 would ultimately be 0. So this is our answer. So let's look at our options. So option B is the correct option. Thank you for watching the video. In this video, you just have to know what is the convolution operator. You just have to see whether the kernel is in this form. Moreover, you should remember the formulas of Laplace transform. Thank you for watching the video.